Hello, this is Team 5's presentation B. Team 5 consists of Ravi, Cutler, Lewis, and Jun. This is a simple objectives tree for the device. The device needs to lift gate, save thorn, obtain the ring and archstone, place a squash ball in the tube, and avoid sensors. Here we see the function tree. Obtaining the ring and archstone is highlighted in the bottom left because that is the main function we'll be concentrating on today. We see subfunctions to be extending. The arm needs to extend to be able to get to the ring and archstone. It needs to grasping the archstone and ring so it can pull it back, which is the next subfunction of retract. The hazard quality is broken up into 4 areas. As you can see, there's blue, yellow, red, and green, which will be covered in the next slides. Here is the middle section, which was red. We have highlighted faster ring stone pickup in the customer requirements going horizontal in the center. And then we have 4 engineering requirements: machine moving speed, pickup range, time to orient with smog, and time for a cycle. So these were all given strong or moderate correlations with that customer requirement due to the fact that they were very important in completing that customer requirement. This is the left section, so the yellow section in the total house quality. Again, we have faster ring and stone pickup as the customer requirement selected. And as you can see, the relative weight was 8%. This 8% with going against all the other ones is high. It is the second highest up there. So this task is very important for our team. Here's the correlation portion of which is the top of the house of quality. A simple correlation we see is the machine moving speed and the part flexibility. The parts need to be able to be flexible and move quickly so that we can do all the tasks within the 30 seconds allowed. Here's the house of quality, the bottom section, which was highlighted in green. 2 of the most important engineering requirements that we saw were distance detection accuracy and time to orient with smog. These were rated 19 and 11% each. Distance detection accuracy was given greater than 1 inch. We wanted to be able to detect the distance within 1 inch. And time to orient with smog under 2.5 seconds. Since it's rotating, we wanted to know where it is exactly. Here's our specification sheet. We wanted to be under the given values of, so we put our height to be 17 inches, our width to be 11, and our length to be 23 inches, so we could fit in the box. The ring and stone retriever have some certain specifications that we wanted. The grasping force to be able to grab the archstone and ring of 1 pound or greater than. Retract speed of 20 seconds so we can make it back in time to beat the clock. And they're going to be powered, the arm that is extending is going to be powered by a motor. Next is the morph chart. Highlighted in the center we see the grasp and the retract functions. In our designs following, you'll see some of these designs used. Our team also decided to make a Gantt chart to organize ourselves as a team and know who's doing what in our task and how we can progress through time. We also made a project planning tree. Highlighted on the left is the product prototype and finalized design. These are the stages that we're in now. After the individual contest, which was a prototyping session, we decided and went back and picked the lifting gate mechanism that we thought would work best, and now we're finalizing a design for this competition, retrieving the ring and archstone. We have 2 prioritization matrices here. On the top you see the prioritization matrix of completing the task. Highlighted in red you see the number 1 priority for us was claiming the 1 ring or archstone, which is the task this week. On the bottom you see the prioritization matrix for steps in the building process, which number 1 is buying materials. Here's a job responsibility matrix that we as a team did to break down who's in charge of what and who's helping who and what. Here we see concept 1. There is a lever arm in the middle to open the gate. The archstone retrieval arm on the right hand side is on a door slider. A motor will retract the door slider. Thorn's retriever arm is at an angle so that you can go straight to the bottom of the base of the bowling pin. It's going to be retracted on an air compressor, and a solenoid will release the lever arm weight to swing it up. Concept 2 is like a pendulum. There will be weight attached to the center rod to swing the gate lift arms open, which will be released with a weight release mechanism there in the center by a solenoid, and an Arcostone retrieve arm will swing out and make a circular motion to just knock out the ring into the center platform. Concept 3, similar to concept 1 and 2, a weight will drop, swinging open the gate release arms. Mouse traps will fling open so that we can get that extra distance to get under the gate. On the right, you can see a door slide that will release the Arcostone ring retrieve arm. Here's concept 4, known as the Destroyer. Has 2 gate lift arms that you can see, labeled 2. Labeled 1 is a 2 door slider mechanism by pulleys, so they'll slide, that whole platform up top will slide out. 3, you can see the squash ball placement arm that'll come out with it and drop into smog. You can see a close-up view on the right hand side, labeled 3. And then 4 will be it's a brush that will sweep and rotate and pull the ring out from the center, the Arcostone and the ring from the center. Here we do a concept evaluation matrix of the 4 concepts we designed, and concept 4 is the winner. So our final design will be concept 4, known as the Destroyer, and here you can see concept 4 sitting on the track ready to destroy. Thank you.